This is a Carboline production.
The traditional method of insulating industrial storage tanks and transmission piping has been to wrap it in mineral wool or foam or the like, and then cover it all up with metal or plastic cladding. It's been the industry standard for decades, but it doesn't need to be. My guest today is Michael Stelmach, a strategic account manager here at Carboline, who will explain how lots of people could save lots of time, stress, and money by insulating their assets differently. Michael, why are you the right guy to talk to about this topic?
So this year, October, will be 30 years that I've been in the industry, but I started off as an industrial insulator and fireproofer. So started off as an apprentice, worked my way up through the craft. It was around the late 1990s that I started using insulative coatings within our other insulation methods. But before, there was a really big concern about corrosion under insulation. We really utilized it on geometry that was hard to insulate, so tank roofs, spheres. And then I migrated to a company that all they did was sell and manufacture thermal insulation coatings.
So your introduction to the insulative coatings was from the viewpoint of this is one of the methods you can use to do this. Can you give just a quick synopsis of all the common methods?
So yes, traditionally, and we're speaking mostly in the oil and gas, I've never really done a lot of what we call commercial applications, be it hospitals and stadiums. So in the oil and gas industry, you've got products like mineral fiber, cellular glass, calcium silicate, urethane foams, all with typically a metal cladding, sometimes with a PVC cladding.
Is it fair to say that the liquid applied insulative coatings is not in the same ballpark in terms of how the industry understands it, or is it sort of on the level with all the other ones? They do recognize it, but it's just not as common.
Correct. So it's a lot more common than it was back in the 90s. But your traditional insulations that I just talked about, they've been around for decades and decades and decades, and they've been used widely in specifications from the EPC level to the owner level. And in this insulative coating being thin film, when I say thin film, you're comparing inches of conventional insulation to 40, 60, 80, 100 mils of insulative coatings. And so it's a little harder to understand the concept. And so it is our job to get out and educate, and more importantly, not to over specify the insulative coatings. There are people, there are companies that go and say that you'll have better energy retention day one with the thin film insulation coatings as you would with 3 or 4 inches of insulation. That's just not the case. You really need to teach your customers, your potential customers, that you will, when you're trying to save energy, when you're trying to save BTUs, you will have a slightly decreased performance over brand new traditional insulation. But in the turn, 5 and 10 years down the road, when you're starting to see corrosion under insulation starts with having moisture in the insulation, which very degrades the insulation value. So 10 years from now, you could have a better insulation performance with an insulative coating than with a mineral wool style conventional insulation.
Talk about the technology with those traditional methods. You were comparing the thickness of these traditional methods versus the much, much thinner coating. But what's happening, physically with these thicker applications? How are these actually working?
Well, they work solely off of thermal conductivity. So they're tested in a lab at various temperatures, depending on the temperature withholdings of the insulation. They could be from cryogenic up to thousands of degrees, and there's different levels of thermal conductivity. And you'll see typically there's a decreased performance the hotter the temperature that you get. And the problem is you put the metal cladding on for protection of the insulation, mostly from weathering and rain. And every time there's a penetration, you're going to have to cut that metal cladding and you put caulking on there to keep moisture from ingressing into the insulation. The problem is that caulking only is going to last, depending on temperature, about 5-7 years, and it becomes brittle, and then it has no sealing properties at all, and then moisture can get in. That's one of the most common mechanisms for moisture to get into the insulation, degrade the insulation value, and help create corrosion under insulation. And in the 30 years I've been doing this, I have not run by very many companies at all that have a maintenance program that they say 5 years after we insulate this tank, this tower, this piping, we're going to go back and inspect the insulation, inspect the cladding, inspect the caulking. So that's where the corrosion under insulation really gets started.
And then as far as the chemistry or the physics behind the liquid applied coatings, if we were to compare those two, what is happening there? Again, how it's actually working? How is that stopping the movement of temperature away from where you want it?
What you have is you typically have an acrylic, an epoxy, maybe a silicone resin. That's the paint or the binder that holds the insulation together. And the traditional insulative coatings have these hollow ceramic particles inside. Some people call them spheres, but really, if you look underneath a microscope, they look like pieces of popcorn that have been blown up in a microwave. And so the air that's entrapped in these particles is the number one method of insulation. Air is Mother Nature's best insulation method we have. These ceramics are also highly reflective to heat, and combine that with the irregular shaped geometry. When heat is trying to escape out of the tank or the pipe, it hits this irregular shaped geometry, and it's going to go naturally to the path of least resistance. And many times that is actually reflecting back into the substrate, into the tank, causing for a highly effective insulation material.
What has the evolution been of the liquid applied insulative coatings? Has it been pretty stable over the few decades that it's gained in popularity, or always getting better, or what's the status of all of that?
It's getting better. When they originally came out, you had a choice of acrylic, or acrylic. Great technologies. They work well. They work well as actually support a little bit of the insulation value. One of our newer products, Carbotherm 551, is an epoxy base. So it has advantages that it can go on double the thicknesses of most acrylics, and it's also a lot more rigid. So it lends itself to new construction a lot better. With the acrylic technology, it's very soft. So if you applied the material on piping in a shop and then you had to transport it and install it, you're going to beat the technology up pretty easily. The epoxy version is a lot more robust and can withstand that impact much, much better.
I guess it's interesting to me how long these have been specified, right? The track record that these have had over, longer than both yours and my lifetimes, and probably longer than our lifetimes combined. But they do have some serious issues that we need to think about. Probably the most common and critical of them is the water will always get in. It's not if the water gets in, it is always, it will. It's just a matter of time. So tell us more about what can happen once that infiltration occurs in a traditional insulation material.
Yeah, so once water gets in, number one, you're creating a corrosion cell, but number two, your thermal conductivity goes through the roof. And I like to give an example is if you were in Alaska in February and you had a choice of a thin but dry jacket, but a damp, big, thick, puffy jacket, which one are you going to wear? I personally would wear the dry one because as soon as you put on a jacket that's wet, you're actually pulling energy out of your body. So it's going to do worse than not even wearing a jacket at all. And the same thing goes with traditional insulation. There's one inspection method for insulation using a thermal imaging camera. And when you take that image, you want to see a green or blue, which means it's cool. When you see areas that are red, and most of the time you see those red areas in areas like where you have a ladder and you have brackets that are going through the insulation and attaching to the metal, you'll see a lot of red. And the red means that it's super hot. So that insulation, one, is not doing any good at all. Two, it might actually be drawing out more heat than not being insulated at all because it is wet.
The moisture that can infiltrate these traditional systems is brought to them by the weather, but the weather is responsible for other types of damage too. And this gets to in some cases, pretty frightening examples of damage due to weather. Tell us what you have seen happen before.
Times in the Houston area, especially, this is near and dear to my heart. Hurricane season is terrible for these plants and for the insulation. And it doesn't necessarily have to be a hurricane, but a tropical storm, a tropical depression can produce enough wind to damage the insulation. And what happens is, one, you have the aluminum cladding traditionally, who is through time and UV degradation has oxidized and become not as strong as the day it was installed. The wind gets in between the gaps of the metal cladding and just rips it apart. We have one client close to our headquarters. They have 220-foot asphalt tanks, and wind in the St. Louis area will get strong enough, it'll get underneath that, and it actually blows the entire 220-foot insulation system off of the tank roof and is blown typically on a public road right next to the facility.
So obviously the danger to anything that's nearby, people or property, it's clear what could happen.
Yeah, and in a hurricane, there's typically not a lot of people working in a refinery. But I was in the panhandle of Texas a long time ago, and before I finished the meeting, there was a safety meeting that was set up because a piece of aluminum cladding got blown off of the tank and actually went through a contractor's vehicle's windshield.
Yeah, it's not like a pop can flying around. It's aluminum. We think light and bendy. That's not necessarily how these things are when they're the size that they are and the thickness they are for that job that they're doing.
Yeah, the aluminum is a lot thicker than the aluminum can, and it's typically corrugated, which makes it more rigid, and it comes in sheets that are about 3 foot by 8 to 12 feet long. So it's a serious hazard.
I want to shift gears to before any of that happens during a construction project. The method that is used to construct these legacy systems, let's call them, creates some challenges for the job site. And I know that primarily people are familiar with these applications in the oil and gas side, typically an exterior setting. It's not the only place where you have this, and consequently, it's not the only place where we would say, you know what, you should consider a liquid applied solution. But talk us through the space that's required and just the amount of stuff involved in installing one of these traditional systems.
There's a lot of storage that goes with this. When you're insulating piping, you have insulation that is molded to be fit directly around a piece of pipe. It's 2 half moons that come together. And so you store these, they're 3 foot long typically, and you store them in boxes, and it takes a lot. You're storing a lot of air, so it does take a lot of space. And I was just reading in an insulation publication that comes out every month through the National Insulation Association, and talking about a whole different industry with the data centers. These data centers have 32-inch piping that can run a mile long. And one of the biggest constraints they have in the construction of these data centers is just the storage of the insulation. So in a 3 foot long box, you have room for one piece of this half moon section. So you literally have 1.5 foot in a pretty big box. So what we're telling our clients is, one, you can use an insulative coating and apply it in a shop environment and have pre-insulated piping come to your job site where all you have to do is the welded connections and eliminate that storage concern. And then also when you are insulating these large bore pipes that are elevated, it's going to require scaffolding because it's hard to do traditional insulation off of a man lift because it's on a 30-inch pipe. It's going to take one person on each side. So you can have tens of millions of dollars of scaffolding that can now be eliminated by pre-insulative coating piping, and what is left, the welds, it can be done easily off of a man lift.
Yeah, they're not inching down, foot by foot. It's more like segment by segment. It is much faster work.
That is correct. And you can just imagine having a scaffold that is miles long on a construction site, what that does to the other crafts, the mechanical crafts, the electrical crafts who have to navigate around the scaffold that's there just to support the insulation work.
If there's any industry or any segment where people are very interested in speed, I can't think of one that there's more pressure to go fast than that one.
There's no doubt about that. It is all about speed to market in that industry for sure.
If we can go back to performance characteristics, what we use to when we have these claims about, the performance is very, very good, the thermal conductivity is low. The way we know this, we study this by doing thermal analyses, and it's something that obviously you have lots of experience with. So walk through that part of this. Like how does somebody take that leap from, okay, your argument about a liquid applied solution seems like it makes sense, but let's make that reality. How do you step through to, here's the data, here's the proof, this will perform the way that I'm saying that it will. It's a knowable figure. These are knowable numbers after all.
Yes. So start off when you have an insul coating or any insulation, you send it off to a third-party lab who tests the thermal conductivity. So they are the ones that give you your K value, or sometimes you will call it R value. So that is not a manufactured number that we come up with at all. The tool that I use to show clients how it will perform thermally is a program called 3E Plus, and that is provided by the National Insulation Association. So you, Tobias, could download that program right now and use it yourself. And so it has pre-populated types of insulation that we talked about earlier in the podcast. Then it has specific ones to manufacturers. Being that insulative coatings are relatively new, we input the information ourselves. So you create a new data point for, say, Carbotherm 551, and you plug in the thermal conductivity test that we ran was run at 3 different temperatures because that is the temperature limits of our resin system. We put those in by temperature and by thermal conductivity. And so then you can perform a thermal analysis, which you pick the substrate. So it could be the sidewalls of a tank, the tank roof, a piping system, a tower, whatever it is. You put in your material at various thicknesses, and it comes back and tells you the BTU savings along with a percent savings. So we typically try to achieve an 80% efficiency with BTUs. Now we're just talking energy retention and BTU savings, but you can also run these calculations and use this technology for process stability, personnel burn protection, anti-sweating, anti-condensation. There's hundreds of different reasons for insulating something, which this program will help you calculate all those.
You showed me once an example of this. You gave me the printout that this developed. Can you talk through that example without naming names, of course, but what were they trying to achieve in terms of the process parameters that they wanted to kind of stick close to? And then knowing that, what did that lead us to in terms of our specification?
Typical oil and gas company out of Oklahoma. Lots of wind in Oklahoma, so they have a lot of that wind damage, lots of rain as well. When they originally insulated the tank. They used a traditional, I think, mineral fiber insulation with the metal cladding. And as we already discussed, it started degrading through time. So we got on a meeting with their tank department, explaining the characteristics, the good and the bad. As we said earlier, you're not going to have that exact same insulation value day one, and I try to address that up front. So we went through the technical process, and they went out for bidding both traditional insulation and insulative coatings, and saw there was one, a cost savings. But they knew the reason they were talking to us is because they had really, really bad CUI. Before they could do anything with the insulation, they had to replace the top 4 feet of the tank because the CUI had eaten all the way through, and you had gaping 3 foot holes in the metal that was the tank itself. A fuel oil tank that operated around 150 degrees. I was pretty confident that 150 degrees in Oklahoma was going to be an 80 mil or 2 coat application, but I always give at least 3 thicknesses. So we showed the thermal performance at 60 mils, 80 mils, and 100 mils. So at 60 mils, we were 77% efficiency. At 80 mils, I want to say we were around 82. And then at 100 mils, it was around 84%, somewhere close to there. And when you use any insulation system, it is not the requirement of the manufacturer. It's really the decision to the end user of how much money they want to spend on the insulation system versus how much they want to save. And the neat thing with that specific tank, they were so happy with the application, they had an internal summit in Houston about 2 years ago that they asked me to speak at. And I told my boss the best thing I did when I presented was actually stop talking, because as soon as I shut up, everybody at the plant was talking about how great the customer service was with us training the contractor. And then what I really enjoyed, one guy had said that they were testing how much steam was going into the plant when it had traditional insulation on it, after the insulation was stripped, and after we applied 80 mils of Carbotherm 551, and post application they were saving a lot of energy, a lot of steam, even compared to the traditional insulation. And to be fair, that traditional insulation was, we know, wet because of the CUI that occurred.
Which leads me to want to ask, because you've mentioned it one or two times already so far, that the insulative value on day one of the legacy systems probably, or maybe even always, is going to be better. How good is it on day one?
Oh, it works excellent on day one, but you get areas like in Houston, well, when you open the bucket, the amount of humidity we have, you're losing some insulation value. But you should, if you get a quality insulation company to do your installation, they do the metal cladding correctly and the caulking correctly, you're going to have a good insulation for about 5 years. And if the company, the owner, would go above and beyond and create a maintenance program for that insulation, they can extend the life of it. But in my 30 years, I haven't seen that once. But that's the beauty of an insulative coating. It's really install it and forget about it. I have applications I can go back over 20 years and see that it's still working and performing like it did at the install.
Which, as you said earlier, you wouldn't expect a legacy method to have similar performance. One thing I did also want you to cover, though, was, since you've mentioned corrosion under insulation several different times, the way that you even know that is happening is not easy to determine, right?
Well, it's because it has the metal cladding on, so it's impossible to know unless you dig into it. So methods of evidence that you might have CUI is using that thermal imaging camera. It's not definitive, but it's gonna pretty much tell you you've got moisture in your insulation and you should inspect it. One major oil and gas company, their policy is that every 3 to 5 years, depending on the temperature of the piece of equipment, they will remove 25% of the insulation. If they find corrosion, they basically have to strip it until they don't find corrosion anymore. But most of the time, if you find it at 25%, you're going to find it at 100%. So they have to go through that every 3 to 5 years. And this is outdated numbers, but that particular oil and gas company globally had 6,000 pieces of equipment that they had to do this inspection for every 3 to 5 years. And only the inspection part was $2,500 a year. And that ranged from very small pieces of equipment to large pieces of equipment. And that was $2,500 was an average, but just hundreds of millions of dollars over and over only to inspect for CUI. And of course, if they find it, then they have to spend millions of dollars to sandblast, recoat, put CUI coatings on, and re-insulate those pieces of equipment.
Might be a bit of an understatement, but it's quite a destructive test and quite a costly, it's like doing a repair job, even when a repair wasn't initially what you signed up for. It's just a fact of the inspection.
You're going in blind every time. There's critical parts, like on a piping system, at an elbow or a 90, it's more common to have CUI there than on a vertical run. So there's areas that they can start off with. But yeah, it's very, very costly just to see if you do have corrosion.
Since so many of these applications are outdoors, I'm sure a lot of folks are listening to this and thinking, okay, what do we do about a top coat? Must I always top coat an insulative coating, or can I get away with not doing it?
Well, let's talk about the whole system. First of all, most of these materials, including ours, are water-based. So it is a very good idea, and we always recommend putting a primer on the substrate first. Not very picky of what type of primers, epoxy, modified epoxies, just about anything can be used as long as it creates a barrier coat. And if you apply the water-based coating directly to a standard water-based coating directly to carbon steel, you'll have what's called flash rusting. It'll almost look like freckles that bleed through the coating. So let's get the prep done. Let's do the application. Now, most of these materials are spray applied, and that scares a lot of people. And I can't speak for all materials, but I will speak for our two technologies that we have. You apply it with an airless, but they are what are called dry fall materials. So in about 10 feet or less, that overspray, if you would, becomes a dust that you do not have to worry about getting overspray on other pieces of equipment. And we'll go back to that application in Oklahoma. I always suggest to the end user to install those black hunting targets downwind of the application. I think it protects the applicator, protects the owner, protects the manufacturer. So they took my request and applied those downwind, and they actually took the airless and not even sprayed at the tank. They just sprayed open air about 30 feet from the target, and there was no overspray at all on the target. And now top coat. You want a top coat for a variety of different things. Acrylics typically don't require a top coat because they are UV resistant. Our epoxy is a modified epoxy, so it does not chalk as aggressively as a standard epoxy, but it will eventually chalk. So if you want your tank to look good 5-10 years from the application, you'll want to top coat it for UV degradation. You also might want to top coat it if you are downwind of a cooling tower that might get constant moisture on the system, cause possible mold growth, or have chemicals in it as well. So chemical resistance, weathering resistance are the two main reasons that you'd want to consider a top coat.
So how do these things pencil out in terms of cost? If you were going to do an installed cost of a typical liquid applied system versus the typical mineral fiber and aluminum cladding system, how do those work out?
As a rule of thumb, generically speaking, there's about a 20% total installed cost of an insulative coating versus traditional insulation with metal cladding. Now that can go either direction. So let's start on the negative side. If you have a 1/2 inch line that goes perfectly straight for a mile, we're going to be more expensive because you're going to have a lot of product loss due to overspray. And I specifically said straight for a reason. The more complex the geometry, the more expensive it is to traditionally insulate. So if you take that same half-inch line, but you put 150 elbows on it that require a lot more labor and different cladding materials, that drives the cost of traditional insulation up. And for us, as a coating standpoint, it's just square foot. So it doesn't matter how many bends. On the other side, one of the most expensive things to insulate in the oil and gas industry is a sphere. So you can imagine if you have a 80-foot giant sphere in a refinery, first you got to scaffold it, which is very expensive to scaffold because you're trying to scaffold around a 75-foot ball. So the scaffolding could be $2 million on that versus with insulative coatings, that scaffold actually gets in your way. So you want to actually work off of a articulating boom, which is a lot less expensive than the scaffold. And then on a sphere, you have to have engineered segments that are almost like little triangles that are curved to go around the geometry of a sphere. And then you have to cut these long, what's called metal gores out. So you'll have about 350 strips of metal that you have to install. And for us, again, it's just square footage. So it doesn't matter if it's flat or if it's round. It's very, very cost effective on a geometry like that. And I want to say apples to apples, traditional insulation with metal cladding with scaffolding on a sphere, you're going to be about 15%, so an 85% cost savings when you look at the total installed cost. But again, those are few and far between. So I usually just say an average of a 20% cost savings.
So with all of the discussion about how great the liquid applied is, in like a real world scenario, when would you argue against one of those?
Great question. First is temperature. So these technologies work pretty well to control sweating around 50 degrees in the Gulf Coast area, and they're good to about 350 degrees. So anything cryogenic, anything below freezing, is just not a good fit for. And even with traditional insulation, there's insulation materials that are designed for cold, and there's insulation materials designed for hot. And insulative coatings are more a cool to hot application for an insulative coatings. And then above 350 degrees, and there are some that have a little bit higher temperature threshold than that. What happens if you apply a traditional insulative coating that's good to 350 at 500 degrees, what's going to happen is the inner layer is going to char. The outside might look good, but the inner layer is going to char. It's not going to be bonded to the surface. And you have a mechanism that you can start corrosion again because you're not bonded to the surface. Those are the two main ones that I veer away from.
So if you were going to wrap it up and give maybe, like the 2 or 3 sentence elevator pitch for liquid applied insulative coatings to a receptive audience, what are you telling them in 2 or 3 sentences?
Yeah, so it's a technology that in many cases, but not all, can replace the need for traditional insulation with metal cladding, in that it eliminates any risk of corrosion under insulation because unlike a traditional insulation system that the corrosion is hidden, you have total visual inspectability of the substrate at all time without removal.
Yeah, I think that's one of the most, compelling secondary benefits of all of this is that there is no loss of visibility at all. There is no mystery of the condition of that asset. You can see it all the way around.
Absolutely. A very correct statement.
I hope that you are ready to make very correct statements now with these 4 questions I have for you, Michael, because some of them might be controversial. Maybe you might start making some people angry, so we'll see. But my first of those 4 questions is a bit of a softball. If you could do any childhood activity as a grown man and knew you wouldn't be judged for it, what would you do?
Oh, that's a great question. Just pretty much anything now. I'm worried about tearing a ligament or something. So just any athletic sports that I don't have to worry about tearing a hamstring. I have twin boys, and we were at baseball practice one time, and we decided to mix it up. And the last 20 minutes, it was coaches versus kids, the kickball. And I knew time was wrapping up, so it was my last kick, and I tried to make it a doozy, and foot went up. Then I was chewing grass in pain, and my child is laughing at me, calling me old because I just tore my hamstring.
Bet you'll never do that again.
Not without stretching. And I did try to stretch, but every time I tried to do a stretch, I had a baseball coming at my face.
Question number 2. What job did you dream of having when you were young?
It definitely was not in insulation or being in the corrosion industry. There's no doubt about that.
Really?
I think my number one goal was to be an astronaut or at least a naval pilot, but definitely did not see myself in the corrosion industry. And I say the week I got the best sleep was the week in physics that they talked about thermodynamics. Because I mean, when am I going to use thermodynamics in my career, right?
I hear that a lot from people around Carboline is this isn't the sort of field you necessarily think you're going to find yourself in, but you just sort of do.
Absolutely. No doubt about that.
Good to see that you're another example that proves the rule. Time to start making some people mad. In your opinion, Michael, what Texas sports team has been the most disappointing recently?
Right now, it's the Houston Astros. We need pitching so desperately. I had a laugh very early in the season. My brother gave me a stat that we broke a world record in baseball, that we had the absolute worst record in baseball, but we had scored more runs than any other MLB team.
Oh, my goodness.
Yes, and it's continuing down that path. Now, the Houston Texans are they've disappointed me since the conception in 2002 of a new team. So I've just learned to realize that I will never see the Houston Texans in a Super Bowl. And to be fair to the Astros, they have spoiled us for a very long time. They have been an outstanding team for a very, very long time, with and without the controversies that I know you want to talk about.
Oh, you know what? It's been beaten to death, so I guess we don't need to go. We don't need to contribute to it. All right, here's a would you rather. Would you rather never eat barbecue again or never eat chocolate again?
For a guy that doesn't have a sweet tooth, it would never eat chocolate again. And I think I would lose my title of Texan if I claimed never eat barbecue again. I'd have to be specific of Texas barbecue.
You know, I almost went there. I almost was going to say, what is the barbecue that's better than Texas barbecue?
There isn't one. But I will say my wife, when we were dating, for her work, she went to Manhattan quite a bit. And she made a comment that our relationship almost didn't get past, that she said there was a great barbecue place in Manhattan. And so one of my travels, I was in New York the same time as her. And I think the comment that I said was, let's go to this barbecue place that I know I'm going to hate just so I can prove you wrong, basically. And I got to admit, it was really good. When you sit down first, you get your placemat is a map of the continental US, and it is all the places that the owner learned to cook barbecue. And the menu is very eclectic, that it had Texas brisket, but it had St. Louis ribs and other ones. And brisket's really where the Texans, we take it seriously. Don't put sauce on our brisket. Don't mess with it. It's just dry rub. But I can appreciate other types of barbecue as long as you don't mess with the brisket. So I was proven wrong, and it was a really good barbecue place.
And if the owner's listening, as I'm sure he is, because who wouldn't listen to this?
Exactly.
I'm sure they'll be very happy to hear your rave review. And speaking of rave reviews, I'm sure that's what we'll get after all the millions of people who listen to hear this episode. So, Michael, thank you very much for sharing what you know with us.
You got it. Thank you for having me.